Hi, welcome back. I would like to talk about Random Forest Classifier today. Before starting with Random Forest methodology, I want to give a quick recap of what we had done or covered last time. We talked about developing decision tree classifiers from scratch in the Python environment using one of the Kaggle datasets called income disparity. We had identified a bunch of X variables or independent variables such as age, education, marital status, country, to identify a group of or a pocket of customers who have the highest income disparity. So we are going to continue on the same exercise, but quickly pivot onto random forest classifier. The reason being the model accuracy can be enhanced significantly. That's my hypothesis. We'll test it out today. And since it's very relevant to talk about hyperparameter tuning, which is also aimed at improving the model accuracy, we shall cover both of these aspects today. Let's first start with decision tree algorithms, which we had already covered last time. Do a little bit of hyperparameter tuning, and then we can pivot gears or switch gears to random forest classifier and see which one of the combinations of the hyperparameters that we can choose and random forest will give us the most accuracy and makes the best sense for the business. The one trade-off we want to keep in mind is if you are improving the model accuracy by spending more money on the computation. Usually, random forest algorithms need higher computational power and might take much longer if you are handling hundreds and hundreds of millions of rows. In that case, a simple trade off we want to bring to the table is we are able to improve the accuracy from 65% to 85% with an additional cost of $100,000. If that's a solid trade off, you might win the business. Without any further delay, let's get started. This is the data set we were looking at last time, the income disparity. And we had selected these independent variables and trained the model for the dependent variable salary in order to identify the group of customers with highest income disparity. So today I'm going to introduce a couple of hyperparameters called Genie and Entropy. We'll look at what they mean in more detail as we keep developing the model or retraining the model. So I've added a new criteria called Genie, and then I'm going to retrain the model to see how that's going to improve the accuracy. Okay. All right. Looks like this is these are the model evaluation criteria. So I'm going to copy that right here. That's the first one. Okay. And now these are previous model training exercises, so I'm going to clear that out and repopulate them as we look at the data much closer. Okay, so the first case is we have trained a decision tree classifier and we have used Genie as a criteria. So with these two combinations, we have achieved an F1 score of 46% and an overall accuracy score of 80%. So that's a good benchmark to have. And then let's go ahead and select the other alternatives to see if it is improving the accuracy of the model or not. So let's go back to our modeling and change the Genie to entropy and retrain our model and see how that's going to affect the accuracy. Okay, clearly, I think there is a slight difference. Let's take a note of that and see how that's making a difference to the model parameters. Right, so we have entropy in here. So with this combination, we have pretty much the same ballpark for overall accuracy score. So I'm not too worried about that. I do want to understand how the F1 score has changed. So it is slightly lower. So the clear winner is Genie in this case. Now let's pivot to random forest methodology and see how the overall accuracy of the model is improving. Okay. Let's go back to the model and bring in the random forest algorithm to start with. So I'm going to import the random forest ensemble import random Forest Trade Classifier. Okay, I'm going to run that real quick. And now I'm going to add the training step for the random forest. So the syntax is pretty much the same with a few tweaks. So extension of decision trees to random forest classifier. Okay, so I am going to call this random forest classifier. Relabel that, and then I'm going to keep the criteria the same. Maybe start with Genie. While we are changing these, I want to quickly talk about Genie and Entropy. So Genie and Entropy are both a measurement of impurity, how pure the classifications are. Genie varies from 0 to zero point 0.5 and entropy varies from 0 to 1. Both are good criteria depending on the actual use case. In a lot of healthcare use cases, entropy is used because it creates much more balanced decision trees. And also, if you are worried about computational efficiency, Genie is slightly better. But today we are going to compare and contrast amongst the four of these combinations and pick the best performing model. So going back to this random forest methodology and see how the performance is going to enhance and model accuracy is going to improve, let's run random forest classifier this time with the criteria Genie and see how that's going to change or impact the model accuracy. Okay. All right. So we do have a higher accuracy looks like, but let's put that down here. So random forest Genie is the first combination. Okay. So now we are going to do a quick comparison of these model evaluation metrics. The accuracy had certainly improved when compared to overall accuracy had improved when compared to the decision tree algorithms. That's good to know. And what is significant here is the recall has increased significantly by 20%, right? So you are avoiding some errors or reducing the error rate by increasing the model accuracy. You're simply pivoting from decision tree algorithm to random forest, which is training multiple decision trees with number of features and type of features, changing them and training multiple decision trees. So it is an extension of random decision trees, and in order to improve the accuracy of the model. So as you can clearly see, the 20% increase in the recall or the overall increase in the F1 score, that is a great way to understand how balanced is your model, how is it performing in terms of both the precision and recall. F1 square is a good metric to assess in these scenarios. So I'm going to highlight both of those and then go back to the model and see how entropy might change the things. I want to believe Genie is the winner for decision tree, and that should be the case for the random forest as well. But let's just find out. Okay. So yes, looks like that's the case too. So in case of random forest, we are also going to standardize on Genie as the winner for the criteria. It's good to experiment and find out. And since the overall model accuracy score is in the same ballpark, I'm not going to highlight on that, but the weighted average is slightly better for Genie. That's the one thing I want to highlight. And the actual increase is in the recall. So it had increased at least 20% when we pivoted from decision trees to random forest, and also the F1 score had increased, which is a great metric to consider while evaluating the classification algorithms. Okay, so these are the model parameters I have looked at to understand the model accuracy, and I am concluding that decision trees, by pivoting from decision trees to random forest, we are able to achieve at least 20% higher recall. If that's a deal breaker, your business should be very much in line with how you are taking this decision. So showing this clear comparison between the different models and different hyperparameter tuning you have done will actually strengthen their idea about how well your model is performing and and make a certain and clear decision for your use case. That's all for today, and we can catch up again for more modeling techniques probably very soon.